Okay, this is a short video on logical operators in Python. First, what is a logical operator? It is a operator which works on true and false values, sometimes called Boolean values. There are a number of Boolean operators in Python, and what I'm going to do for each of these is tell you what operation or what the name of it is, what operator we use in Python. I'll give you an example of what the use of that operator looks like, and then we'll talk about the truth table for that operator. So the first one I want to talk about is the AND operator. If you want to use the AND operator in Python, the keyword is lowercase and an example, this is going to look like A and B. And then we'll have the truth table that we'll talk about. So when you have a truth table, A is going to have a true or false value, B is going to have a true or false value, and then I'm going to show you the result of executing A and B. So the way you read this is the right hand column, A and B is true if A and B are true. So we'll go through the combinations for two variables which can contain two values. There are going to be four combinations. So the first combination is false false, which is going to evaluate to false. The next combination of A and B is false and true, and A and B is going to evaluate to false. The third combination is true and false, and that's going to be false. And then finally, in the last case, A and B are both true, so the expression A and B will be true. So that's what a truth table is. It shows you the possible values and result of an operator. The other thing I want to mention is most modern languages represent true as 1 and false as 0. So if you kind of look at my combinations of false and true, but use zeros and ones, it would be 0, 0, 0, 1, 1, 0, 1, 1, which in binary is 0, 1, 2, 3. So that's usually the combination that you will see the truth tables in, because that's the basically correlates to a sequence of binary numbers. The next operator we're going to talk about is the OR operator. In Python, it is a lowercase or, and the example would be A or B. And then to create our truth table, the expression A or B is true if A or B is true. So as long as one of them is true, the expression is going to be true. So in the first case, they're both false. So A or B would be false. In the second case, for false and true, A or B would be true. For this case, A or B would be true because A is true. And then finally, if they're both true, we only require one be true, but both being true will also result in A or B being set to true. Another operator we have is the NOT operator, sometimes called the complement operator. It is represented by a lowercase not in Python. An example of it is not A. So this is what we call a unary operator. That is, it operates on a single value, whereas the other ones we looked at are binary operators because they work on two values. In the case of the truth table, we have a true or false for A and then the result of not A. So we're going to have two entries in this truth table. The first is where A is false and not false is true. and if A is true, not true is false. So that's the truth table for not. Now then, these are Boolean operators that work on Boolean values. There are some logical operators that are referred to as bitwise operators, and that is they take a binary representation and then they go through bit position by bit position and apply whatever logical operator you are talking about. So the first one we have is bitwise and the operator in Python for bitwise and is the ampersand sign. As far as an example, it's going to look like this: A and B, and then again stressing that this is for each bit. What's going to happen is we're going to have the 4 combinations, and ultimately this truth table is going to be exactly the same as it was before. Again, the only exception is instead of working on a Boolean variable or a Boolean value, it's going to be doing this bit for bit. We do have a bitwise OR, and the operator for that is the vertical bar, sometimes referred to as the pipe symbol if you kind of come from the Unix world. An example of this is going to be A or B, and again the truth table is going to be the same, except we're going to apply this for each bit pair. So like I said, the truth table is going to be the same as the OR that we talked about before. One operator that we may or may not have mentioned is exclusive OR, written as XOR, and the operator for exclusive OR is the caret symbol, and it's going to look like A caret B, which you would read as A exclusive OR B. Now then, the truth table for exclusive OR is the expression A exclusive OR B is true if A or B is true, but not both. So it's a slight variation on the OR operator. So it's going to start out looking the same. Neither value is true here, so the result of A caret B is going to be false. Here B is true, so the result is true. The next one, A is true, so the expression is true. So A or B is true, but not both. And in the last case, we do have true and true, so that's going to evaluate to a false. So like I said, that was a really quick discussion on logical operators in Python.